Hello, Legacy Sabers, Marsh here. So today we're going to write quadratic functions. You're going to want your notes, foldable, and then you may need a calculator to do some simple mathematics today. Our essential question today, how do I write a quadratic function given some key information? So, general forms of a parabola. There are two forms that we're going to be working with quite a bit during this video. Vertex form, which is the one that has the parentheses, a parenthesis x minus h squared. Translated form is another way to look at that. Okay. Intercept form is when we look factored. Some people like to call this factored form. Okay. Steps to writing our equations. Depending on what we're given as information, we need to decide which form to use. And there's going to be bits of information that tells you which form should you use. Then we're going to take that key information. We're going to substitute it into the form that we're going to pick. They're going to give us a random point, x and y. We're going to solve for an a, and then we're going to rewrite our equation. So it's kind of going to look a little different. We definitely do need to pay attention to what kind of form do we need to use. And we're going to discuss that as we do our examples. So first example here. Write the equation of a parabola that has a vertex of negative 3, 2 and passes through the point 4, 5. So remember, we have our vertex form, which is y equals a x minus h squared plus k, or we have our intercept form, which is y equals a x minus p x minus q. Okay, now being that I have a vertex, I should probably use vertex form, right? So what we're going to do is we're going to plug in the vertex. That is our h and our k. My vertex is negative 3, 2. This negative 3 is the x value, so I'm going to put it with the x, and the 2 is the y value, so I'm going to put it with the k. So my vertex form is going to look something like this. Y equals a x plus 3 squared, because remember, this is left 3, so remember it's opposite of what we see. And then plus 2, because I would go up 2 to get to that dot. Now that you've substituted your information in, you now have an ordered pair for x and y, because we need to find the stretch. We don't know what the a value is. So we're going to plug the 4 in for the x, the 5 in for the y. So I'm going to get 4 plus 3 squared plus 2. So I'm going to get 5 equals a 7 squared plus 2. Now be careful, something that's common a lot of people try to do is they try to add these two together. Okay, that is not the case. Can't do that. Nope, nope, nope. Because this is technically 7 squared times a. So I'm going to rewrite this so I can see that. I'm going to write that as 49a plus 2. Okay. Subtract 2 because I'm solving for a. We're going to get 3 equals 49a divided by 49. Oh, gross. 3 over 49. I wonder, can we simplify that fraction at all? Let's check it. I'll use my calculator to check that fraction. Nope. That is my a value. 3 over 49. So I'm going to take that value and whoop, plug it in right up there. So I'm going to get y equals 3 over 49 x plus 3 squared plus 2 for my final answer. I know, a little kind of strange, right? But ultimately you need to decide what information do you have for which form, plugging in the dot that they give you for x and y, solve for a. So, another one. They are giving us the equation of a parabola that has x-intercepts of negative 1 and 6. So and then passes through the point 1, 5. If I'm given intercepts, I should probably use intercept form, right? That would make the most sense because I have intercepts. So what we're going to do is take these intercepts and we're going to pop them in. Ultimately, what I'm going to be thinking is if I had the intercepts of x equals negative 1 and x equals 6, what would I have solved to get x equals negative 1? Well, I would have solved x plus 1. right? So I'm going to go y equals a, and then I'm going to put x plus 1, because that's what I would have solved to get x equals negative 1. And then I would have solved x minus 6 to get x equals 6, right? Now I need to plug in the point 1, 5. So 5 equals a, 1 plus 1, 1 minus 6. Okay, do some math quick. 1 plus 1 is 2, 1 minus 6 is negative 5. I'm going to get 5 equals a times negative 10. So I'm going to divide by a negative 10 to get a alone. So we get negative 1/2 equals a. So I'm going to get y equals negative 1/2. I'm just going to go and take that value and pop it back in there. X plus 1 for my final answer. Just like that. So you definitely have to pay attention to which form do you need, and then pretty self-explanatory once you get there. Let's try another one. So I have the equation of the parabola that has x-intercepts of -9 plus or minus I squared roots of 5. That's disgusting. And passes through the point of 7, 9. So now there is two x-intercepts here, -9 plus I squared root of 5 and -9 minus I squared root of 5, right? That is technically what that is. So this one I have intercepts, so I'm going to have to use intercept form. So I'm going to remind myself what that looks like. Like that. So now this is going to look kind of strange. I'm going to start with y equals a, and then my x-intercept is -9 plus I squared root of 5. So I'm going to say x minus, and I'm going to put parentheses behind it so I see what that looks like. Okay, because this is my intercept. Now I got the other one as well. So minus -9 minus I squared root of 5. Okay, now I need to clean this up, right? Before I plug in my x and my y, I should probably clean this up because this is absolutely disgusting. So let's do distributive. Let's get rid of one set of parentheses. So I have x minus, plus 9, because negative into negative, minus I squared root of 5. Okay, same thing here. I'm going to distribute that negative. X plus 9 plus I squared root of 5. Now, you're probably thinking, oh, Marsh, please don't tell me I have to distribute. I don't want to triple distribute. We do, right? Everybody needs to multiply. What I'm trying to do is get rid of the I, so it's a lot simpler looking. So we're going to clean out this I, so I'm going to have to triple multiply. So x is going to multiply by everybody over here. 9 is going to multiply by everybody over here. And so is that I squared root of 5. So x times x gives me x squared. Now this a is just kind of coming along for the ride. I'm just kind of dragging him along. So this is the y. Kind of forgot that they exist for a while because I'm just cleaning up the gross. X times 9 is 9x. X times I square root of 5 is x I square root of 5, something like that. 9 times x is 9x. 9 times 9 is 81. 9I square root of 5. Okay, 9 is done. So I get negative x I square root of 5, negative 9I square root of 5, and negative I squared square root of 5 squared. Because I square root of 5 times I square root of 5 would be I squared times square root of 5 squared, right? Okay. Y equals A over there. Okay, let's do some simplification here. So I have y equals a, well, x squared I think is the only guy. There we go. Cross him off. I have a 9x. I have a 9x. And that's all it looks like I have. So that means I have 18x. Okay, cross those guys out. Xi squared root of 5. I have a negative xi squared root of 5, so those guys cancel out with one another. Same thing with the 9i squared root of 5 minus 9i squared root of 5, so we're doing really, really awesome there. This guy, well, square root of 5 squared is just a 5, right? So this is technically negative I squared times 5. Negative I squared, that is a negative 1 times 5. So that is technically a 1 times 5, so it'd just be a 5, right? I know it takes forever to understand, but technically that'd just be a positive 5. So I have 5 and an 81, which gives me an 86. What you guys have just done is you have undone the quadratic formula. That's kind of neat, actually, if you think about it. So you've just undid the quadratic formula to get it to work. Let's plug in the 7 and the 9. So, because I still need to get that A. Oops. Plus 18 times 7 plus 86. Okay. I need a calculator. 18 times 7 is 126. So this is 49 plus 126 plus 86. This is going to be the big number, people. Plus 49 plus 86. 261. So 9 equals A times 261. Does 9 divided by 261 simplify? I don't think it does. Oh, it does. 1 over 29. So I'll get 1 over 29 equals A. Final answer, guys. Take that. Now, I'm not going to go all the way back up to this grossness, right? I spent time. I'm going to make sure he goes in up here. So my final answer, y equals 1 over 29 x squared plus 18x plus 86. Now, if you wanted, you could distribute that 129th and make it look prettier. I'm not going to do that, but you could if you wanted. I'm not going to, because that's just going to take forever. Okay. Last example, story problem. Dun, dun, dun. But we got this. Freya launches a rocket from a tower that is 119 feet above the ground. The rocket reaches a maximum height of 1,026.52 feet after 7.53 seconds. Write an equation that models the height of the rocket y in feet as a function of time x in seconds after launch. Then determine when the rocket will hit the ground. Okay, anytime I do a story problem, I draw a picture. So we're on a tower. So she's up here somewhere, right? So there's Freya standing there. Okay. And she's going to launch a rocket. So she's standing on a tower. Whoop, whoop, whoop. So she's launching a rocket. Okay. Technically, it probably should have been from back there. Just fix that here. Okay. So she's launching a rocket from the tower. Now notice that would be the y-intercept, right? Where she launched it from. And then we know that the maximum height, so right here, we know the maximum height was 1,026.52. So what I'm going to do is I'm going to make a little note. So this is 119 feet off the ground. This is 1,026.52 feet off the ground. And I know that the time it took was 7.53 seconds. Now, they tell us that the y value is going to be the height, and they tell us the x is the time. So that means ordered pairs are going to be time, comma, height, which is very normal. Time usually is the x value when you're looking at a story problem, because time usually is the independent variable, and your y, your dependent variable, is dependent on the time. So here's what I know. I have a y-intercept of 0, 119. That is how we started our graph. I know also that I have a maximum of 7.53 seconds time, comma, my height, which is 1,026.52. Now, this is the maximum, aka a vertex, right? Because that is, if you look at the picture, it's the vertex that we just found. So that means I can't use intercept form because I don't have intercepts. I have a vertex, so I got to use my vertex form. So I'm going to do a little reminder up here. So this is what I'm trying to do. I'm going to plug my vertex in for my h and my k. So y equals a x minus 7.53 squared plus 1026.52. Let's plug in our ordered pair 0, 119. So 119 equals A, 0 minus 7.53 squared plus 1026.52. Okay, 7.53 squared. So I get, doing my negative 7.53, and I squared it, I got 56.7009. Again, be very careful. Do not add these two values together. Okay, they can't. This is multiplied by A. So I am going to have to subtract 1026.52. So I get 109 minus 1026.52. I'm going to get negative 907 fingers 52 equals 56.7009A. So dividing, I'm going to divide by that 56.7009. We get an answer of, rounded to 2 decimal places. Pretty much negative 16. It's negative 16.005, so pretty much negative 16. My official answer then, if I take that and go plug it in, I could go, whoa, sorry guys, we zoomed out. There we go. Y equals negative 16, x minus 7.53 squared plus 1026.52 for official answer. Now, here's what's cool about this graph, or this equation. I could now figure out where the graph, they forgot about it. I got to finish that actually. Then determine when the rocket will hit the ground. Well, Marsh has ran out of room, hasn't she? Ooh, do-do-do-do-do-do. Let's move on to the next slide. Okay, so my equation was y equals negative 16 x minus 7.53 squared plus 1026.52. I need to determine now when will the rocket hit the ground. So basically that's telling us, so if we draw our picture again, so she goes right here, right? I need to know right here, aka I want to know x-intercepts, which means I want y to be equal to 0. So I'm going to say 0 equals negative 16 x minus 7.53 squared plus 1026.52. So now what I'm going to do is I'm going to basically solve for x. So I'm going to subtract that 1,000. Okay, so I'm now negative 1026.52, negative 16, x minus 7.53 squared. Now remember, you're not going to distribute that negative 16. You're going to divide by negative 16. And you're also not going to square that. Who wants to square that? Let's just work on cleaning up stuff. So I got 1026.52 divided by 16. I get an answer of 64.5575 equals x minus 7.53 squared. Square root both sides. Gotta stay in this whole radical, so I gotta literally use my calculator for everything, people. There we go. I get pretty much 8, but I'm going to round it to 3 decimal places, I think. So 8.01 is pretty much what I'm going to get there. Equals x minus 7.53. I do need to remember, though, that there's a plus and minus there. Add 7.53 because I took a square root. That's the reason why. Okay, so I have 2 different possibilities. I have 8.01 positive version plus 7.53, which will give me 15.54 seconds. It's time. And then if I do the other way, I would have a negative 8.01 plus 7.53, which is a negative 0.48. So this is 8.01 negative plus 7.53. And that is negative seconds, which makes absolutely no sense, right? Because you can't have negative seconds. So we could just cross that out. So our answer, we hit the ground at 15.54 seconds after launch. And that is the end of our video. I know this stuff is pretty confusing, but the main thing is you need to decide what do you have. So if you have an intercept, you got to use intercept form. If you have a vertex, you have to use vertex form. And as we practice it and work with it a little bit more, you definitely will get a little bit more comfortable with that. But until then, I will see you later, Sabers.